On December 21st, 2012, that was supposed to be the end of the world. No, it had something to do with the Mayan calendar. I know that in the Mayan chronology, it wasn't supposed to be like the end of time, but it was just like the end of a long cycle, and basically like a birthday for the universe. But while nothing really seemed to happen, and it was just an ordinary day for most people, something interesting did happen for me around that time. Within just the span of a few days. I don't remember if it was exactly on the 21st, but it was within a few days of it. I was really busy working, and so I don't exactly remember the exact date, but I started developing this idea about the universe, like a model for an alternative model it ended up being about how the universe was created. And so just like jumping into it, I have a model, an alternative Big Bang model that takes a two-dimensional slice of the vacuum, or actually just however many dimensions there are. Just imagine a plane cutting through it, and so then that's going to capture just a slice of all the dimensions. So it's going to look like a two-dimensional piece, but it's actually cutting through all the like however many n dimensions there are. And so you just have a slice of a n-dimensional vacuum, a planar slice with no boundary. And I wanted to set up a system that would not only allow for me to be able to understand how the universe, how the Big Bang happened, but how the external structure of the multiverse is constructed. So what it is I envisioned two bodies, two masses, a positive mass and a negative mass, and they're separated in space-time, and they're attracted to each other, but they're on opposite sides of this slice of the vacuum, and they can't directly interact with each other. You know, they want to collide and annihilate each other, like matter and antimatter, but I allowed the space-time in between them to be curved, so they're always falling towards each other, but they can never directly interact. And in the warping of the space in between them is where I hypothesize that universes are created. And if you just imagine the boundary of a universe having zero thickness, it's like you can lay an infinite number of boundaries on top of each other. And so whenever these two masses are attracted to each other, as they presumably in this model they would have always been set up like this, and you have like a tearing effect in the middle, and it causes like tears in space. And so even though like you've got that perfect planar vacuum in the middle, like you have all these like sheets of the vacuum that are like coming unfurled, and so in the field, they're like, the field is just basically like an asymptotic, like, circular argument, basically. Like, if you're in one quadrant, you're coming up like this. If you're in the other quadrant, it goes down like so, above the plane. And then the two below the plane are going down. And then the fourth one coming back up like that. So it's going to create a torque, essentially, and which allows for the vacuum in between them to just not be isolated in one space, or that allows for the fluctuation of the vacuum to not be isolated in one place. So it's actually like going along the plane, like ripping up the vacuum, and so it creates like this rippling effect. So you get like waves on the ocean, and I believe that it's truly the ocean of chaos that actually exists wherever that creation comes out of. This is an idea for a perpetual motion machine, like the one and only true perpetual, or maybe not the one and only, but like, I mean, this is like the perpetual motion machine that created an infinite number of universes already, and will always do this. Like, it's like so these fields, or these, like, you know, you have what I refer to as like differential vacuum densities, like, but I mean, it's not very well defined because I'm not that smart, but it's like you have open systems, like you tear, and all these are open, but then remember the two fields, one's going up and the other one's going down, but as the field pushes down, you know, vacuum curvature, like the curvature of space, and the other one's coming up, and whenever they meet precisely in the right, well, you know, just parallel with each other, like in 3D, not just in 2 dimensions, but above the plane. And when two waves line up properly, they create a closed system, and it seals itself. And at that point, you have a closed system that's now bound onto the vacuum. And so it's like a tent volume with so it's a finite volume with an infinite surface area, and it's entropically, thermodynamically bound onto the plane, and it's just sinking, depressing down quickly at first, and then it slowly starts to just spread out more and more. And the Big Bang then becomes just the the tip of the iceberg, so to speak. Like, I believe that we're only seeing we're only envisioning the top of it, and that the big upset would be that the universe was actually at its maximum volume at the Big Bang. So as everything is pushed out, the volume of the universe that we're in is actually getting smaller. And basically the way that you can test for this, which means that this is an actual scientific theory, is to use the Doppler effect on light. And what we could do is look for a linear trend in the blue shifting of galaxies, because as everything is like moving out and we think that space is like, Euclidean, like flat or whatever, well, it could be roughly flat, but still, everything like seems to be expanding out evenly, but that could just be a false positive. Like, it could be the case that, most of the material, whenever the sealing event happened and the quote unquote like Big Bang event, shoom, and like all the material from all the matter, all the energy and that turned into matter and the collision, and boom, all coming out. Well, it's like if the plane is down here, then all the material, all the galaxies would still seem to be roughly going out in like equal directions. But then as the universe gets older and older, you're going to see like less and less motion in that direction. And so I mean, it's both like looking for a linear trend in things seeming to be going, galaxies having a linear trend, and then later having more of a outward trend. So it's like we need to be really modeling the movement of all of the galaxies, or a good many of them, get like a good sample of galaxies all around us, and then just, again, like, this might not show up for many millions or billions of years, because our universe is like presumably like not very old yet in terms of how much longer it's going to last. But the end result in this model, as you can see, is totally like a planar expansion. So you eventually lose all vertical expansion and everything is squished flat. So the end of the universe would be the big squish. The big squish is something to be avoided, and if possible. And I got to thinking that since universes would drape to infinity, then if you think about it, like, every universe along the plane would share a common volume. I mean, a common. Yeah, they're all touching at infinity, basically. So every universe is really just one universe, and so